Hey everyone, welcome back to our YouTube channel. This is Sanyukta from Vista InfoSec. If you are passionate about web security or just starting your journey into the world of APIs, you are in the right place. In today's digital landscape, APIs are the backbone of modern applications, but they also come with their own set of vulnerabilities. In this video, we'll be diving deep into the OWASP top 10 of API security risk, from broken object level authorization to security misconfigurations. We'll break down each risk, explore real world examples, and discuss best practices to keep your API secure. Whether you are a developer, a security enthusiast, or just curious about how to protect your applications, this channel will equip you with the knowledge you need to defend against the most common threats. But before starting, don't forget to hit that subscribe button and turn on notifications so you never miss an episode. Let's get started on the securing the future of APIs together. In this video, we'll cover what is API, basics of API, types of API, and most important, what are the OWASP top 10 of API security risk. Welcome to the first edition of OWASP API Security Top 10. If you are familiar with the OWASP Top 10 series, you'll notice the similarities. They are intended for readability and adoption. Otherwise, consider visiting the OWASP API Security Project on Wikipedia before digging deeper into the most critical API security risk. API plays a very important role in modern application architecture. Since creating security awareness and innovation to have different paces, it's important to focus on common API security weaknesses. The primary goal of the OWASP API Security Top 10 is to educate those involved in API development and maintenance. For examples, developers, designers, architectures, managers, or organizations. What is API security? A foundational element of innovation in today's app-driven world is the API. From banks, retail, and transportation to IoT, autonomous vehicles, and smart cities, APIs are a critical part of modern mobile, SaaS, and web applications and can be found in a customer-facing, partner-facing, and internal applications. By nature, APIs expose application logic and sensitive data such as personally identifiable information, that is PII, and because of this have increasingly become a target for attackers. Without a secure APIs, rapid innovation would be impossible. API security focuses on strategies and solutions to understand and mitigate the unique vulnerabilities and security risk of application programming interfaces, that is APIs. What are the basics of API? What is API? API is a type of software interface offering a service to other pieces of software. Why we use API? To enhance the speed of development, security, and scalability. Endpoints. APIs operate through request and responses. HTTP request URLs are nothing but the endpoints. So what are the type of APIs? There are two types of APIs, which is REST and SOAP API. So first we'll see what is REST API. REST stands for Representational State Transfer and refers to the architectural rules used when building APIs, programming interfaces that allow connecting two services and interface in the same code base. Software that complies with REST architecture requirements is known as RESTful. To be RESTful, an application needs to support multiple components and interactions. The codebase should be semantically simple, performance efficient, and allow the introduction of additional services. What is SOAP API? The SOAP stands for Simple Object Access Protocol, a protocol for granting access to web services to connect and exchange data. Access protocol use typically XML information set, most often HTTPS. Each SOAP protocol is comprised of three parts: an envelope, which contains instructions of message processing and its structure; encoding rules, means defining specific of data transfers for particular instances and databases; and conventions, in conventions, managing calls and responses to execute procedures. Each message in SOAP is completely standalone and independent. All the information that you need to get a response is present in the message itself. You can predict the structure of responses based on the request, which makes a code base more reliable and easier to control. It helps that all messages follow the same rule as well. So basically, let's see the difference between REST and SOAP API. REST API works with XML, JSON, and HTTP plain text. In SOAP API, it works with XML by design. REST API is loose and flexible guidelines based on the architecture. In SOAP, it is strict, clearly defined rules. REST API has modest security, SOAP API has advanced security. REST API works well with data, SOAP API works well with the actions, or you can say processes. REST API uses low bandwidth and is highly scalable. And also in SOAP API, it uses more bandwidth but with limited scalability. So this is all about the type of APIs. Now we'll move forward to the API OWASP top 10 risk, which we'll list down here, and I'll elaborate all the impact, definition, and remediation further in next slides. So the first API vulnerability is broken object level authorization, then broken user authentication, after that excessive data exposure, then lack of resources and rate limiting, after that broken function level authorization, then mass assignment, a security misconfiguration, injection, improper assets management, and insufficient logging and monitoring. These are the OWASP top 10 list of API security risks of 2019 edition. So this will cover in further slides. The very first example of a security risk is broken object level authorization. Object level authorization is an access control mechanism that is usually implemented at the code level to validate that one user can only access objects that they should have access to. Every API endpoint that receives an ID of an object and performs any type of action on the object should implement object level authorization checks. The checks should validate that the logged in user does not have access to perform the requested action on the requested object. Failures in this mechanism typically leads to unauthorized information disclosure, modification, or destruction of all data. So I'll give you one example of attack scenario. An e-commerce platform for online stores provides a listing page with the revenue charts for their hosted shops. Inspecting the browser request, an attacker can identify the API endpoints used as a data source for those charts and their pattern. Example /shops/shop name and then the file name. Using another API endpoint, the attacker can get list of all hosted shop names with a simple script to manipulate the names in the list. Replacing the shop name in URL, attacker gains access to the sales data of thousands of e-commerce stores. So this is the simple example of broken object level authorization attack scenario. In broken object level authorization, attackers manipulate ID of one resource in API call with the ID of resources belonging to the other user. This happens just because of lack of proper authorization check. Server components does not fully track the client state and relies on the parameters like object IDs sent by the client. It is also known as insecure direct object reference, as we have seen it in web applications. It is called as IDOR. Impact of that is data disclosure to unauthorized parties, data loss or data manipulation, or full account takeover. What are the prevention for that? Implement a proper authorization mechanism that relies on the user policies and hierarchy. Use an authorization mechanism to check if the logged in user has access to perform the requested action on the record in every function that uses an input from the client to access the record in database. Prefer to use random and unpredictable values as GUIDs for the records instead of IDs. Write tests to evaluate the authorization mechanism. Do not deploy vulnerable changes that breaks the test. Next is broken user authentication. Authentication in APIs is a complex and confusing mechanism. Software and security engineers might have misconceptions about what are the boundaries of authentication and how to implement it correctly. In addition, the authentication mechanism is easy to target for attackers. Since it is exposed to everyone, these 2 points makes the authentication component potentially vulnerable to many exploits. There are 2 sub-issues: lack of protection mechanisms, which we can say API endpoints that are responsible for authentication must be treated differently from the regular endpoints and implement extra layers of protection. Second, misimplementation of the mechanism. The mechanism is implemented without considering the attack vectors or its wrong use case. Example, an authentication mechanism designed for IoT clients might not be a right choice for web applications. What are the impact of broken user authentication? Getting other users' identity, gaining control of other users' data, performing actions on behalf of other users. So, what are the preventions for that? Make sure you know all the possible flows to authenticate the API. Ask your developer what flow you missed. Don't reinvent the wheel in authentication, token generation, password storage. Use the standards. Authenticate all APIs properly. Treat credential recovery or forget password endpoints as login endpoints. Provide brute force, rate limiting, and lockout protections. Implement multi-factor authentication. Next vulnerability is excessive data exposure. Exploitation of excessive data exposure is simple and is usually performed by sniffing the target to analyze the API responses, looking for sensitive data exposure that should not be returned to the user. APIs relies on the client to perform the data filtering. Since APIs are used as the data sources, sometimes developers try to implement them in a generic way without thinking about the sensitivity of the exposed data. Automatic tools usually cannot detect this type of vulnerability because it is hard to differentiate between legitimate data returned from the API and sensitive data that should not be returned without a deep understanding of the application. The API returns sensitive data to the client by design. This data is usually filtered on the client side before being presented to the user. An attacker can easily sniff the traffic and see the sensitive data. Impact of that, it leads to exposure of sensitive data, and prevention for excessive data exposure is never rely on the client side to filter sensitive data. Review the responses from the API to make sure they contain only legitimate data. Backend engineers should always ask themselves who is the consumer of data before exposing a new API endpoint. Avoid using generic methods such as toJSON and toString. Instead, cherry pick specific properties you really want to return. Next vulnerability is lack of resources and rate limiting. API requests consume resources such as network, CPU, memory, and storage. The amount of resources required to satisfy a request greatly depends on the user input and endpoint business logic. Exploitation requires simple API request. No authentication is required. Multiple concurrent requests can be performed from a single local computer or by using a cloud computing resources. It is common to find APIs that do not implement rate limiting or APIs where limits are not properly set. Exploitation may lead DOS, making the API unresponsive or even unavailable. Prevention for lack of resources and rate limiting is defined proper rate limiting. Limit payload sizes, limit all calls to API per minute or hour. Add proper server side validation for query string and request body parameters. Enforce maximum size of data on all incoming parameters and payloads. Next vulnerability is broken function level authorization. The best way to find broken function level authorization is to perform a deep analysis of authorization mechanism while keeping in mind the user hierarchy, different roles and group in the application. Exploitation requires the attacker to send legitimate API calls to the API endpoint that they should not have access to. These endpoints might be exposed to anonymous users or regular, non privileged users. It is easier to discover these flaws in APIs since APIs are more structured and the way of access certain functions is more predictable. Example, replacing the HTTP method from get to put or changing the user string in the URL to admins. Authorization checks for a function or resource are usually managed via configuration and sometimes at the code level. Implementing proper checks can be a confusing task since modern applications can contain many types of roles or complex user hierarchy. Example, sub-users, users with more than one role. Impact of this vulnerability is such flaws allow attackers to access unauthorized functionality. Administrative functions are key target for this type of attacks. So, prevention for this vulnerability, your application should have a consistent and easy to analyze authorization module that is involved from all business functions. Frequently, such protection is provided by one or more components externally to the application code. The enforcement mechanism should deny all access by default, requiring explicit grants to the specific role for access to every function. Review your API endpoint against function level authorization flaws while keeping in mind the business logic of the application and group hierarchy. Make sure that all of your administrative controls inherit from an administrative abstract controller that implements authorization checks based on the user group or role. Next vulnerability is mass assignment. Objects in modern applications might contain many properties. Some of these properties should be updated directly by the client, and some of them should not. An API endpoint is vulnerable if it automatically converts client parameters into internal object properties without considering the sensitivity and the exposure level of these properties. This could allow an attacker to update object properties and they should not have access to. Example for sensitive properties like permission related properties, process dependent properties, and internal properties. The impact of mass assignment is it can lead to privilege escalation but tampering security mechanism bypass. Prevention for this vulnerability is don't bind incoming data and internal object properties or variables blindly. Set read-only to properties that are sensitive. Read-only properties can be read by client using get method but cannot be updated or modified using put method. Next vulnerability is security misconfiguration. In this vulnerability, attackers will often attempt to find unpatched flaws, common endpoints, or unprotected files and directories to gain unauthorized access or knowledge of the system. Security misconfiguration can happen at any level of API stack from the network level to the application level. Automated tools are available to detect and exploit misconfiguration such as unnecessary services or legacy options. The API might be vulnerable if appropriate security hardening is missing across any part of application stack or if it has improperly configured permissions on cloud services. The latest security patches are missing or systems are out of date could be a threat for security misconfiguration. Impact for security misconfiguration vulnerability cannot only expose sensitive user data but also system details that may lead to full server compromise. Prevention for the vulnerability is a repeated hardening process leading to fast and easy deployment of proper locked down environment, a secure communication channel for all API interactions across two static assets to prevent exception traces or other valuable information from being sent back to attackers. If applicable, define and enforce all API response payload schemes including error responses. Ensure API can only be accessed by specific HTTP words. All other HTTP words should be disabled. API expecting to be accessed from browser-based clients, example web app front end, should implement a proper cross-origin resource sharing, which is CORS policy. Next vulnerability is injection. In injection vulnerability, attackers will feed the API with malicious data through whatever injection vectors are available, example direct input, parameters, integrated services, etc., expecting it to be sent to an interpreter. Injection flaws are very common and are often found in SQL, LDAP, or NoSQL queries, OS commands, XML parsers, and ORM. These flaws are easy to discover when reviewing the source code. Attackers can use scanners and fuzzers. If the API is vulnerable to injection flaws, when client supply data is not validated, filtered, or sanitized by the API, client supply data is directly used or concatenated to SQL, NoSQL, LDAP queries, OS commands, XML parsers, and object relational mapping or object documentation mapper. Data coming from external systems is not validated, filtered, or sanitized by the API. Impact of the injection vulnerability can lead to information disclosure and data loss. It may also lead to DOS or complete host takeover. Prevention for injection vulnerability is perform data validation using single, trustworthy, and actively maintained library. Validate, filter, and sanitize all client provided data or other data coming from the integrated systems. Special characters should be escaped using the specific syntax for the target interpreter. Prefer a safe API that provides a parameterized interface. Always limit the number of written records to prevent mass disclosure in case of injection. Validate the incoming data using sufficient filters to only allow valid values for each input parameter. Moving towards next vulnerability, which is improper asset management. In improper asset management, the API might be vulnerable if the purpose of an host is unclear and there are no explicit answers for the questions. Old API versions are usually unpatched and are an easy way to compromise systems without having to fight state-of-the-art security mechanisms which might be placed to protect the most recent API versions. Outdated documentation makes it more difficult to find and fix vulnerabilities. Lack of assets inventory and retire strategies lead to running unpatched systems, resulting in leakage of sensitive data. It is very common to find unnecessarily exposed API hosts because of modern concepts like microservices, which make applications easy to deploy and independent. Impact of this vulnerability is attackers may gain access to sensitive data or even take over the server through old unpatched API versions connected to the same database. Prevention for this vulnerability is to inventory all API hosts and document important aspects of each one of them, focusing on the API environment, who should have network access to the host and the API version. Inventory integrated service and document important aspects such as their role in system, what data is exchanged, and its sensitivity. Documents all aspects of your API such as authentication, errors, redirects, and rate limiting, cross-origin resource sharing, policy, and endpoints, including their parameter, request, and responses. Regular upgrade all API versions. Disabling exposed API on non-production environments. Document all aspects of API such as authentication, error, redirects, cross-origin resource sharing, policy parameters, and request responses. Keep API documentation updated. Next vulnerability is insufficient logging and monitoring. In this vulnerability, attackers take advantage of lack of logging and monitoring to abuse systems without being noticed. Without logging and monitoring, or with insufficient logging and monitoring, it is almost impossible to track suspicious activities and respond to them in a timely fashion. The API is vulnerable if it does not produce any logs, the log level is not set properly, or log messages do not include enough detail. Log integrity is not guaranteed. Example, log injection. Logs are not continuously monitored. API infrastructure is not continuously monitored. Scenario for this vulnerability is access keys of an administrative API were leaked on a public repository. The repository owner was notified by the email about the potential leak, but took more than 48 hours to act upon the incident, and access keys exposure may have allowed access to the sensitive data. Due to insufficient logging, and company is not able to access what data was accessed by the malicious actors. Impact of this vulnerability is without visibility over and ongoing malicious activities, attackers have plenty of time to fully compromise the system. And prevention for this vulnerability is log all failed authentication attempts, denied access, and input validation errors. Logs should be written using a format suited to the consumed by a log management solution, and should include enough data to identify the malicious actor. Logs should be handled as a sensitive data, and their integrity should be guaranteed at the rest and transit. Configure a monitoring system to continuously monitor the infrastructure, network, and the API functioning. Configure custom dashboards and alerts enabling suspicious activities to be detected and responded to earlier. This is all about the API OWASP top 10. Since the AppSec industry has not been specifically focused on the most recent architecture of applications in which APIs play a very important role, compiling a list of 10 most critical API security risks based on the public call for data would have been a hard task. Despite there being a no public data call, the resulting top 10 list is still based on the publicly available data, security expert contributions, and open discussion with the security community. I hope you found this video on OWASP Top 10 API Security Risk insightful and helpful. Your support means the world to me. If you enjoyed the content, please give it a thumbs up and share it with your friends or colleagues who might benefit from it. I would love to hear your thoughts or any questions you have in comments below. Don't forget to subscribe for more videos on API security and other tech topics. Stay safe, stay secure, and I'll see you in the next video. Thank you for watching.